Hey everyone, we're going to look at numbers 3 through 5 in section 3.5. So we're going to do 3 of these. Calculating higher order derivatives. So in number 3, we're going to calculate the second and third derivatives of this function here. Notice this is y as a function of r. So r is our independent variable, and it's 1/6 pi r to the 7th power. We want to give exact values. Do not replace pi with 3.14, right? Leave it as pi. Okay, so first derivative, we're going to be using the constant multiple rule and the power rule, right? 1/6 pi is a constant multiple, so I pull it out. And the derivative r to the 7th is power rule. Bring the 7 down, r to the subtract 1 from 7, 6th power. Clean this up, bring this 7 out. 7 times 1/6 is 7/6 pi r to the 6th. So there's the first derivative. Now we need the second and third derivatives. How do we get those? Well, the second derivative is the derivative of the first derivative, right? So I'm just going to take the derivative again. This time I have a constant multiple of 7/6 pi. R to the 6th is 6 r to the 5th by the power rule. Multiply 6 times 7/6 gives me 7 pi r to the 5th. There is my second derivative. Third derivative, take the derivative of the second derivative. So 7 pi now is a constant multiple. The derivative of r to the 5th is 5 r to the 4th by the power rule. 7 times 5 is 35 pi r to the 4th. So pretty easy. Hopefully that makes sense for number 3. Now 4 and 5 are similar in terms of wanting to find this. Number 4 says calculate actually the first, second, and third. So we did calculate the first up here, but they didn't want that as one of the answers. So this time we're going to find the first, second, and third derivatives of this function, 20t to the 6/5 power minus 6t to the 2/5 power. So this is in the form that we can use the power rule. We have a difference rule. First of all, I'm going to take the derivative of this first one minus the derivative of the second one. And then we have constant multiple rule and power rule. So with the first function here, taking the derivative, 20 is a constant multiple, pull it out. Power rule, bring the 6/5 down. And subtract 1 from 6/5, that's 6/5 minus 5/5, which is 1, I get 1/5. And then minus what? Bring the 6 out. T to the 2/5, bring the 2/5 down. T to the, if I subtract 1 from 2/5, 2/5 minus 5/5 is negative 3/5. So clean this up. 5 goes into 20 4 times. 4 times 6, 24. T to the 1/5 power. Minus 5 and 6 have no common factors. So 6 times 2 is 12/5. T to the negative 3/5. And this is what Achieve wants. It'll take that. Now, what if I asked for you to write your final answer without negative exponents? Notice the original problem had no negative exponents. Could we do that? Yeah, remember t to the negative 3/5 is 1 divided by t to the positive 3/5. So I can rewrite it this way. Okay, but for Achieve, this is fine. For you to leave it in this form. Okay, on a test, this would be fine unless you were asked to write your final result without negative exponents. Then you would write it that way. Okay, you could combine this as one fraction. That's not really what I'd want you to do, though, at this point. Okay. By the way, this fractional form here is a little bit easier when you're then, if you have to evaluate the derivative at some point. Okay, so that's the first derivative. The second derivative and third derivative are going to be similar. The second derivative is the derivative of the first derivative. So again, very similar. I'm going to take the derivative of this one minus the derivative of this one. So here, take the derivative of this one. 24 is a constant multiple. Bring the 1/5 down. Subtract 1 from 1/5 gives me negative 4/5. Minus 12/5 is a constant multiple. Bring the negative 3/5 down. Subtract 1 from negative 3/5 gives me negative 8/5. Clean this up. 24 times 1/5 is 24/5, t to the negative 4/5. 12/5 negative times a negative 3/5. Well, negative times negative makes it positive. There's no common factors down here. 5 times 5 is 25. 12 times 3 is 36. So no common factors in the numerator and denominator. Okay. So again, this is Achieve's answer. If you write it without negative exponents, it looks like this over here. Finally, the third derivative is the derivative of the second derivative, and we go through the same thing. 24/5 constant multiple, bring the negative 4/5 down, subtract 1 from negative 4/5 is negative 9/5. Add then 36 25ths constant multiple, bring the negative 8/5 down, subtract 1 from negative 8/5 is negative 13/5. And then just clean this up. Again, no common factors in the numerator or denominator. 24 times 4, notice it's negative. I get negative 96. 5 times 5, 25th, negative 96 25ths, t to the negative 9/5. And then here, positive times negative is negative. Again, no common factors between the numerator and denominator. 5 times 25 is 125. 36 times 8 is 288. So they do want you to leave it in fraction form, not an equivalent decimal. And there's your final answer, again, without the negative exponents. Okay. Now, number 5 is a little different, although we're still finding in this case, like number 3, calculate y double prime and y triple prime. This is the second derivative. It's the third derivative. For y as a function of z, notice in each problem, the independent variable has been different. Here it was r was the independent variable. Here it was t. Here it's z. So it's not always x. Could be other letters. Make sure you're comfortable with those different independent variables. So here's the function that they give. If I'm going to find the derivative of this, I'm going to quickly rewrite, because 1 divided by z is just z to the negative 1 power. And I can use the power rule. Now you could use the quotient rule on 1 divided by z. If you do it correctly, that's fine. But I think it's just easier using the power rule. So if I can rewrite, simplify an expression and use the power rule as opposed to the quotient rule, typically I'll do that. Okay, so I need to first find the first derivative in order to get to the second derivative. So the derivative of z with respect to z is just 1, right? Minus, what's the derivative of z to the negative 1? Power rule. Bring the negative 1 down. So there's a negative 1, z to the subtract 1, negative 2. So I get 1 minus a negative is positive, z to the negative 2. Or you could write that as 1 plus 1 over z squared. But I'm going to leave it in this form in order to find the derivative now of the first derivative, which is the second derivative, right? So here I have the sum of two functions. The derivative of 1 is 0. And then what's the derivative of, this is plus what? Z to the negative 2. Bring the negative 2 down. So plus a negative 2 becomes minus 2. Z subtract 1 from negative 2 gives me negative 3. So I get negative 2 z to the negative 3, which in fraction form would be negative 2 divided by z cubed. And this is what Achieve wants in this problem. Okay. Third derivative, derivative of the second derivative. Again, I would use this one to take the derivative because it's in the form I can quickly find the derivative. Negative 2 is a constant multiple. Z to the negative 3 is power rule. Bring the negative 3 down. Subtract 1 from negative 3 is negative 4. Negative 2 times negative 3, positive 6. 6z to the negative 4 is 6 divided by z to the fourth. And there's your third derivative. Okay, so you got to be really good, obviously, simplifying expressions with exponents. Got to understand negative exponents, and of course the calculus part, the power rule, and all the other sum and difference rule, constant multiple rule, constant rule. So good problems. Make sure you understand these. If you have any questions, as always, let me know.